In this video, we want to discuss the range for each of the 6 trigonometric functions. And this is going to help us figure out if our answers make sense later on. And it also gives us an idea about, good number sense when we're working these problems. So we need to look at these ratios again. So I just wrote these guys down from the first part of these videos. Sine is y over r. Now, before we jump into all this, understand that r is going to be a fixed value. And we're also dealing with, our right triangles that look just something kind of like this, just very generically x, y, and r. R is always going to be the longest side because it's a right triangle and it's going to be the hypotenuse. So y could shrink all the way down to basically where it's 0. And the tallest it can be is like when we really start to open up this right triangle, and it gets steeper and steeper, almost to the point where the y value is the same as the radius. So that's kind of like the limit for that. And we saw that happen when we have these quadrantal angles where it's on the y-axis. So the largest this can be for the y value is r. So the largest it can be is a ratio of r to r, which is 1. And if you look at it going upside down, like starting to tick down like this, then the lowest it can be would be negative r. So for sine, you're going to be bounded between -1 and +1. And the same thing is going to be true for cosine. So the largest that this x value can be is if you were to take this right triangle and flatten it down, where the r, this hypotenuse, becomes the x value. And the smallest it can be is when you start to open this up and you get a steeper and steeper right triangle, but then this x value right here starts to shrink and become 0. So for sine and cosine, the range for these guys will be bracket -1 to +1. Now tangent and cotangent, they're a little bit different because they are ratios of variables y and x. Now, as you get a steeper and steeper right triangle like this, see, watch this progression. Right, if r stays the same, you see that the ratio of y to x gets bigger and bigger and bigger and bigger, really without any kind of limit. But it could also get smaller and smaller as you start to bring it down. The y gets smaller and smaller, and the x starts looking bigger and bigger. Because of that, and when you throw in the negatives as well, tangent can balloon all the way up to infinity, and it can go all the way down to -infinity. And the same thing is going to be true for cotangent. So their range will be from -infinity to +infinity. They can run the entire range of real numbers. Now, cosecant and secant, these guys are weird. And let me tell you why they're weird. So the numerators are fixed, okay? But their denominators are going to be variables. So their ranges get really, really messed up. So for y, as y gets smaller, if we start to bring this down, as y gets smaller, you have a fixed number over a denominator that gets bigger and bigger, or excuse me, you have a fixed numerator over a denominator that keeps getting smaller and smaller. When you have a number over a smaller and smaller number, you start to get really, really big. Like if you were to take, 1,000 and you divide it by 10, that's 100. You divide it by 1, that's 1,000. You divide 1,000 by a tenth, that's 10,000. So you divide it by a smaller number, you get a bigger result. So this guy's going to blow up, but how small can he be? Well, remember that if the denominator gets bigger, the fraction is going to get smaller. But the biggest that y can be, as we saw above, is going to be matching r. So this guy can go from 1 to infinity for its output. And because of the way that we have negatives involved as well, that's going to be -infinity to -1. That's going to be true for both cosecant and secant. This is where these guys live. These are the kind of answers they will spit back out. So using this information, we have some examples we want to work through to see, are these values possible, right? It gives you an idea if the work you're doing is right. Are you on the right track, or did you come up with an answer that just doesn't make sense? Because sometimes it can mean that you typed something into the calculator that's completely wrong. Maybe you didn't close off parentheses, or you just did something bad, right? So if we look at part A, and we have the sine of theta is negative 0.00032. Is this possible? Does that fit within the range for sine? Sine is supposed to spit back a number between -1 and +1. So yeah, that's possible. Part B, can the tangent of an angle ever equal 2/3? Remember that the range for tangent is all real numbers. So yeah, tangent can be anything. That's never going to hold us back. All right, can the cosecant give us 33/17? Remember, for the range for the cosecant, it has to be something that is less than or equal to -1 or greater than or equal to 1. Now, I know we have a fraction here, but remember, fractions can be improper, which means they have a value that's greater than or equal to 1. So 33/17 is something that is greater than or equal to 1, so it is possible for you to have a cosecant value that is 33/17. Think about the picture for that, right? So the way that cosecant is defined is r over y. Is it possible to construct a right triangle so that the y value is 17 and the r value is 13? Yes, that is possible. But consider this. Consider if I have sine of theta is equal to 33/17. So imagine that that's the case. What does that mean in terms of where these numbers come from? Well, sine is supposed to be opposite 33 over hypotenuse 17. This triangle is not possible because you can't have a hypotenuse that's not the longest side in a right triangle. So this doesn't make any sense. This guy can't be. This is impossible, right? And let's look at D. Can the cosine of theta ever equal 72.4? Well, we run into the same issue that we saw when we considered sine of theta equal to 33/17. The range, the output values for cosine have to be in between -1 and 1 inclusive. So can this guy happen? Nope. There's no way that you can go to a calculator and type in the cosine of a number and get 72.4. It's not going to happen. And if you say, my calculator will, let me see your calculator. All right, can the secant ever kick back the number 5/7? Well, consider the acceptable range for the secant is this guy. Is 5/7 a number that's part of that range? The answer is no. Remember that secant is going to be r over x. And if I tried to construct a right triangle like that, where my r is 5 and my x is 7, that is an impossible triangle. We can't do that. Your hypotenuse cannot be anything less than the longest side. So you can't have the leg of a right triangle being longer than the hypotenuse. It doesn't make any sense. Finally, can the cotangent equal 0? Well, since the range for tangent and cotangent is all real numbers, yeah, that's possible. Not a contradiction whatsoever. So again, pay attention to what you're typing in. pay attention to the results and check to make sure that they make sense.